Now, when I say the word factor, what goes through your head? Yes, Liz.
You find the numbers that can equal whatever main number you're given.
Exactly, yes. When I say factor, what you should think of two numbers, or I should say. I shouldn't say two. I should say multiple numbers that multiply to equal your original number. So if I'm trying to find the factors of, let's say 16. Trying to find the factors of 16. Somebody give me one set of factors. 2 and 8. 2 times 8 is 16. What else? 4 and 4. Richard, go ahead. What do you have? Yes, 16 and 1. Are there any others? Say it again. 1 and 16. Because that's the same as 16 and 1 just flipped, we don't really need to repeat that. We're going to step it up a little notch, and you may never have thought of these factors before, but 2 and 8. But, no, it's all right. What if I told you, oh, I heard it. -4 times -4 is also 16. -2 times -8 is also 16. What else? One last one. -16, -1. When we are factoring quadratics, we also need to consider these negative factors as well. Okay. Now, we're factoring quadratics, not just single numbers like 16. And I'm going to tell you the setup for how you should factor. Let's come up with a quadratic here. Let's do x squared minus 8x plus 16. We're going to factor this. X squared minus 8x plus 16. We're being asked to factor this quadratic. Meaning that we need to come up with two sets of parentheses that will multiply together to equal our original quadratic. That's the definition of a factor. Things that multiply together to equal your original, in this case, expression. X squared minus 8x plus 16. Now there's a process I'm going to teach you that kind of just like streamlines your thought process. I want you to draw a big X. Again, this is just a way to organize your thoughts. In general, the X is not needed. It's not necessarily needed. It's just an organizational setup. In this big X, up top, I'm going to tell you, you're going to put your A times C term. Whatever that is, you'll put it in the top of the X. Now, if I say A and C, do you guys know what A, B, and C are in comparison to a quadratic? Where are they? Where's the A? The A is in front of which term? The x squared. The A is the number in front of the x squared. The b is the number in front of what? What's the b term? Oh, you guys, it sounded like you guys knew, but maybe you don't know. All right. The b is the number in front of your plane x, and the c is your constant, a, b, and c. Now, there is no number in front of the x squared. What's invisible there, do you think? A 1. There's an invisible 1 in front of your x squared. So if I tell you a times c goes up top in our x, what is a times c? 16, yeah, because 1 times 16 is 16. So up top goes a times c, which in our case is 16. And in the bottom goes your b term. What is our b term in this problem? Negative 8. So this is the setup. You'll always put a times c up top and b in the bottom. Okay, so now, to create the factors, we're looking for two numbers that do two things. Multiply to equal the top number. But yes, oh, how'd you know? Maybe you do, maybe you were taught factoring, maybe? Ah, okay. And the two numbers must also, at the same time, add to equal the bottom number. Yes. So we've already listed the factors of 16, right? The factors are numbers that multiply together to equal another number. So if we're looking for two numbers that multiply to be 16, lucky enough for us, we've already listed all of the numbers that multiply to be 16. But we are now also only looking for the factors of 16 that also add to give us negative 8. Which one of those sets of numbers also add to give us negative 8? Negative 4 and negative 4. Yes, Liz?
Wait, so they have to multiply to be factors of 1 and 16? Or
Just 16. Just 16. 1 times 16. And you perform that operation. 1 times 16 is 16.
And also add to be negative 8.
Yes. So, negative 4 times negative 4 is the top number 16, and negative 4 plus negative 4 is the bottom number, negative 8. So these are the numbers we put on the sides of our x. So now, we have everything we need to create our two sets of parentheses that tell us the factors of the quadratic. We draw the two sets of parentheses. Both of the parentheses start with an x. So right now what I have written is parenthesis x blank and parenthesis x blank and parenthesis. What do you think goes in those blanks? Oh my gosh, the sides of our x. The negative 4 and the negative 4. So now I have parenthesis x minus 4 and parenthesis x minus 4 and parenthesis, and I'm done. These are the factors of the quadratic. If I were to go ahead and do what I did for warm-up, multiplying these two parentheses together. I'm just going to do it really quickly to show you guys, but I have x times x, and I get x squared. X times negative 4, negative 4x. Then I distribute the second negative 4. Negative 4 times x is negative 4x. And negative 4 times negative 4 is a positive 16. So you get x squared minus 8x plus 16. Does that look familiar to you? Yes, it's the what? It's the original quadratic. So you can see these two binomials do end up multiplying together to equal the original quadratic. They are the factors of the quadratic. If you ever want to check yourself to see if you did this correctly, you can always just multiply the two parentheses together, and if it equals the original quadratic, you did your work correctly. If it doesn't equal the original quadratic, you did something wrong. Are there any questions on factoring so far? I'll do another one. All right, let's go back up to our notes. We'll give us a little break from factoring quadratics, and I want us to remember or recall what a GCF is, because sometimes we're going to have to pull out a GCF before we factor. What is a GCF? Yes? Is it Aiden? Yeah. Ah, yes. Okay, Aiden, did you have your hand raised, or were you stretching? You were stretching. Okay. Yeah, Liz, what's up?
Apparently, according to the notes, it's the greatest common.
Yes, at the top of the notes, it says that a GCF is the greatest common factor. Have you ever practiced pulling out a GCF from something? Pulling out a greatest common factor? Oh, okay. This is why I now realize first period struggled so much, because they had never done it. All that pulling out a GCF is, if we're looking at two numbers, and we're thinking about the factors of the two numbers. So on number 1, it says 2x plus 16. What are the factors of 2? 2 times 1, and also negative 2 times negative 1. What about, I just want us to get in the habit of seeing those negative factors. In general, when we're just pulling out a GCF, we don't have to think about the negative factors, but you do when we're factoring quadratics. And then the factors of 16, name them for me. Just the positive ones. 1 and 16, 4 and 4, and 2 and 8. Good. What is the biggest factor shared by 2 and 16? Bigger, a little bigger. There's one more that's bigger. Not lower. 2. 2 is both a factor of 2 and a factor of 16. Therefore, 2 is the greatest common factor between 2 and 16. So that is the GCF of 2x plus 16. So I'm going to pull a 2 out of both of these terms. Now, when I say pull a 2 out, what operation I mean, can you guess? Close. Division. Because 2 multiplied into 2 and multiplied into 16, to get it out of 2 and 16, we divide by 2. Now, GCFs are always written in the very front once I pull them out. So I'm going to write a 2 and then a parenthesis. And now you're actually doing the dividing. What is 2x divided by 2? just x because those 2's cancel. So now I'll have 2 parentheses and I write an x. And then I divide 16 by 2 and what do I get? So after the x I write a plus 8. End parenthesis. I have successfully pulled a GCF of 2 out of 2x plus 16. All right, I'm going to do a little bit of a harder one. So it's just, your end answer is just 2 parenthesis x plus 8 end parenthesis. Let's see here. Okay. We're going to step it up a little bit. Let's look at number 2. We have 3y squared times z plus 5y squared minus 8x squared times y squared. Well, are there like terms? So technically in this problem, there are 3 terms. The one that starts with a 3, the one that starts with a 5, and one that starts with a negative 8. Do any 3 of those have the exact same variables? So, they don't, none of them have the exact same variables, right? On that first term, we have a 3y squared times z. None of the others have a y squared times z. On the second one, we just have a y squared. None of the others just have a y squared. And on the third one, it has an x squared times y squared. None of the rest have x squared times y squared. So we can't combine any of these because they don't have completely like terms. Instead, we do know that they do share a common factor. What do all 3 of these have? They all have a y. Not only a single y, but a y squared. They all have a y squared. That is the greatest common factor between these 3 terms. I can, because my GCF is y squared, divide y squared out of all 3 of these and put it in the front. And that's what I'm going to do. I'm going to pull out a GCF of y squared, put it in the front of a parenthesis. What is 3y squared times z divided by y squared? What happens there on that first term? Right, the y squareds cancel and I'm left with just 3z. So I have y squared times parenthesis 3z. Now I must divide the middle term. What is 5y squared divided by y squared? It's just 5 because the y squares cancel to be 1. And on the last term, I have negative 8x squared times y squared divided by y squared. What happens there? Yes, the y squareds cancel, so you're left with just negative 8x squared. So my end answer is y squared, parenthesis, 3z plus 5 minus 8x squared, end parenthesis. I have pulled out the GCF of y squared. Let's.
That's all you have to do.
Yeah, that's it. That's it. Because 3, 5, and 8, is there a number that multiplies into all of those? No. 1 does, but it's pointless to pull a 1 out because anything divided by 1 is itself. Now, which ones do I want you to do or try? let me do number 5 with you, and then I'm going to have you guys do 3, 4, and 6. But I'll do number 5 right now. I'm doing number 5 because there are multiple things I can pull out. Multiple GCFs here. I have 8ab squared minus 36a cubed times b. Let's look at the whole numbers first. What is the greatest common factor between 8 and 36? 4. So that is one of the terms I'll be dividing out of both of these terms. I'll divide out of 4. What is the next thing that both of these terms share? What else do they both have? Yeah, they both have a single a. Now, the first a doesn't have an exponent. There's always an invisible exponent of what? 1. Good. So I'm going to divide a out of both of those. What is the last thing they both share? A b. I'm going to divide b out as well. So in front of the set of parentheses, I'm going to put 4ab. Parenthesis. What is 8ab squared divided by 4ab? 2b. The a's completely cancel, and b squared divided by b is just a single b. Because you're subtracting those exponents, remember? 2 minus 1 is just 1. So you're left with 2b there. And then what is negative 36a cubed times b divided by 4ab? Negative what? Yes. So negative 9, then a cubed divided by a is just a squared, right? 3 minus 1 is 2, so I have a squared. And what happens to the b's? They cancel, and I'm done with my answer. I have pulled out a GCF of 4ab. So my end answer is 4ab, parenthesis 2b minus 9a squared. All right, you guys try. Should I do 3 for you? Yeah, do 3, 4, and 6. So I'm going to go ahead and do number 2 in the factoring section. That's the bottom section. This middle section, difference of squares, we're actually not learning that yet. We'll learn that later in the year. So we're skipping that for now. So number 2 on the factoring section says x squared minus 14x plus 48. And we're trying to factor this into 2 binomials, those 2 sets of parentheses. What should I do first? X squared minus 14x plus 48. Yes, I think I heard it. We draw our great big X. What goes up top? Right, the a times c. Whoops. So in this case, our a value is 1. Our c value is 48. So 1 times 48, I should put a 48 up top. What goes in the bottom? Yeah, our b value, which is negative 14. So I have 48 up top, negative 14 in the bottom. Remember, I'm trying to find 2 numbers that do what? that what to get the top. Multiply to get the top, but also, yes, add to get the bottom. So sometimes it's hard to just immediately think of these. You should, if you're struggling on thinking of these numbers, list the factors of the top number. So I'm going to even write that. If stuck, list factors of top number. So I'm going to list the factors of 48. What goes into 48? 1 and 48. 1 times 48. What else? 2 times, what do you think? Anybody? 24. What else? So in my head, I should also be thinking, okay, do any of these so far add to be negative 14?
12, I think.
Yep, 12 times 4 are factors of 48. Do those add to be negative 14? 12 plus 4 is a positive 16. What else? Say it again. 8 times 8 is 64. 6 times 8. 6 times 8. Now, what is 6 plus 8? 14. Okay, so we have the right number, but what's wrong about it? Negative. If we know 6 and 8 are factors of 48, what else do we know? Negative 6 times negative 8 also gives us 48. And what is negative 6 plus negative 8? Negative 14. Is that what you're looking for? Oh, yes, it is. So, what should I put on the sides of my x? Negative 6 and negative 8. I'm not done, though. What's my last and final step to put this in the right format? Two sets of parentheses. What goes into both of them? Right, that's what we're going to end with, is that negative 6 and negative 8 we found in our big X. What goes in front of the negative 6 and in front of the negative 8? X's. So my factors are parenthesis x minus 6, end parenthesis x minus 8, end parenthesis. And I'm done. All right. For homework, you guys have 1, 3, and 4. 1, 3, and 4 of the factoring section. 1, 3, and 4.